the park stuff starts up this week, and I forget, you guys are Wednesday, so what we're going to do, since it's just going to be a nightmare as far as a rotational park between Tuesday and Wednesday, and then again on Friday, I think what we're going to wind up having to do is to go through a bunch of these problems like this, and then I think on Thursday, since we have the shortened periods, it's 25-minute, I believe, we're going to re-quiz. Okay, we'll re-quiz.
Yes.
Okay? Which means staying awake in class is helpful. Yes, ma'am. I haven't decided yet. Yes, ma'am.
So, like, would you take a
If you do better, I usually average them out. Because let's say for example you got, let's say for example you got a 20 out of 25 or whatever it was. Okay, that's pretty good. All right, woo-hoo. Screw it, I'm not studying, and you get a 6. I'm going to average it. Yes, ma'am.
But if I got like the 48% I did, and then I get 100%, then I want the 100%. I don't want to see.
I know.
You should draw the lowest quiz grade.
You could also wish in one hand and the other, see what fills up first. So let's go through this. All right. Now, a couple of things here when you're walking through coterminality. Coterminality is the whole basis upon trig. Being able to flip around and find out what your reference angle winds up being. So finding coterminals, that should be an easy subject to do. Yes, ma'am?
Yeah, the only problem I had was when it was over 9, but I don't know how to solve this.
You don't, because you're not solving for anything in this problem. In that, all you're doing there is finding the coterminal angle between 0 and 2 pi. What happens here is our reference stuff that we wind up looking at in basic terms, we're always trying to find ourselves within one revolution. Okay? Whether it's positive or negative going in the direction, you want to always find yourself within one positive revolution between 0 and 2 pi. So if they're giving you something that is negative 17 pi over 9, it's almost negative 2 pi. Do you agree?
Yeah.
By it being, I have to go clockwise, I come around, and I'm left with what as a reference angle? Pi over 9. That's your answer. Pi over 9.
Oh.
That's it. It's not asking to evaluate, it's not asking to solve, it just said what's the reference? What's a reference, or what's a coterminal angle within one revolution? Within one revolution, it would positive revolution would have to be pi over 9. That's not your secretary.
Did you have to do that, or did you just do it plus 17 over 9?
Means the same thing. Because that's the same thing, yeah. By rounding, by putting it around, it's making me visualize where it places. Okay, get here.
So you have to find a negative in one other?
I just said within one positive revolution, okay? It depends on how much pi was going on and all that kind of stuff. Okay. Yes, ma'am. When you get into the next group is when they start signing, negative 8 pi over 3. Sorry, I thought I was doing this one. Negative 8 pi over 3. That's more than one full revolution. Do you agree?
Yeah.
It's 2 2/3. So it's negative 2 2/3 pi. So there's 2 pi. Now, one of the things you guys tend to mess up is your thirds. Is 2/3 more than a half?
Yes.
Yes. So that means it's got to go past here. Okay? So this is 2/3 of the way. What's left? 1/3. So you have a pi over 3 bouncing down off of pi. So that means to come all the way around for your positive would be 4 pi over 3. Okay? Does that make sense?
Yeah.
Hold on. Shh. Sorry, what's that?
Like add and subtract?
It does, but it's helpful to be able to, when you do it this way, it's also going to help you be able to visualize what quadrant you wind up in. That's why. Izzy, you were saying something?
Yeah, I don't get it.
What? You have to be more specific.
I just like, I thought it was like you were finding the reference angle, so the same angle at the top.
We did find the reference angle. The reference angle was pi over 3. It's pi over 3 away from pi. They're asking for a coterminal angle between 0 and 2 pi, which means they're looking for a positive coterminal angle. They're asking, what is the coterminal angle to this negative 8 pi over 3? Well, a positive comes around, here's pi, and I add a third to it. That's why I have 4 pi over 3. You didn't have to value, you didn't have to solve it, do anything with it. You weren't trying to bounce it in a different quadrant. They're just trying to find out what is that positive angle measure in that quadrant. Okay, that's all that was. All right. And then when you start getting into your trig functions, when you start getting into your trig functions, you have the tangent of negative 600. Both at the same time. Obviously, the first thing you have to figure out is, where does it go? A couple ways of doing this is that you could start spinning it. It's negative, so this is what, 360? Here's 540, and then come up another 60 degrees up. So the reference angle here is 60 degrees. Okay? It's asking for tangent. Now, if I'm at 60 degrees, 60 degree reference angle, root 3, 1, and 2, I'm using that triangle. Do you agree?
Yes.
Okay. Tangent of 60 degrees is root 3 over 1. You okay?
Yeah.
Now, the only other question you have to ask yourself is tangent positive or negative in the second quadrant?
Negative, right?
Negative, correct. It's negative because one of them is positive, the other one's negative.
Just make that negative.
You can do that if you want, that's fine. That's fine, okay? Yeah, Kelly?
How do you know those negative?
It's in the second quadrant. If you remember, what's happening here is if you place it into the second quadrant, your x values are negative. Your y values are positive. Your x value, so your tangent would be a positive root 3 over negative 1, so that's why it's negative root 3. Okay? You place the same idea. Question? What do you got?
Why is cosine x and why is sine?
It's the nature of the beast. What happens here is you start to think, what happens is, when you talk about cosine values, if you're at theta, whenever you're at theta on your unit circle, your theta value is always against the origin, I forgot what that was called. No matter where it's placed, gentlemen, no matter where it's placed, it's always looking at an opposite. See how that is? It's always looking at an opposite. Since it's always looking at its opposite, the opposite is always the vertical component to theta. What it's sitting on, what it's lying on, is its adjacent. So it's always lying on an x value, and it's always looking at its opposite. Does that make more sense? That's why it works. It's the whole idea of being when we would say theta with the terminal side of blah. Negative 315. We spin this one around again. I do believe we get first quadrant with a 45-degree angle. You guys agree?
Yeah.
So your first quadrant, 45-degree angle, what's the sign of 45?
Root 2 over 50.
There you go. No, it's sign positive in the first quadrant.
Yes.
Oh, I see. Negative 315?
It's it's negative 315.
Oh, okay.
What's that?
Oh, I was just gonna say whatever is in the first quadrant.
Everything's. Yep. Okay. Yeah, I know. Yeah, now I know. Do a couple more of the degree ones, we'll go into the radians. Tangent 1050. Now this is probably one where you would subtract out a couple times. You just did that by hand instead of spinning it, right? Or did you just spin it? You just start spinning? Okay. Now, what what some people do is they know that this is well over 1 revolution. Okay? So some people will sit there and say, okay, I'm just going to subtract 360 right off the bat, because then I know I'll still be at the same coterminal angle. Subtract 360 again, I know I'm at the same coterminal angle. Subtract 360 again. If you do that a couple of times, you might just be able, instead of having to spin it around, like if you lose count. Okay. I believe, let's see, 1050 is what? There's 360,
30
720.
30
Going,
Wait, then it's in
like
the,
one more.
it's almost the entire one.
It's
It's
a fourth
30
quadrant.
degrees.
It's a fourth quadrant for 30.
it's over here?
Yeah.
Okay. Or you have other people do it for you. And it leaves you, thank you, it leaves you 30 degrees off down, correct?
Yeah.
So you have a 30-degree reference angle, 4th quadrant, tangent. Will it be positive or negative?
Oh,
It's negative because you have a negative vertical component. So you know it's going to be a negative. Now again, your tangent value of 30. When you're at 30 degrees, what's your opposite?
What?
1, what's your adjacent? So it becomes, very good, with the negative, negative root 3 over 3. Notice how all I'm doing is I'm finding that reference angle, bouncing it into my triangle, evaluating, finding the value. That's all this breaks down to be. You all right? It's okay. It's all right. I saw you talking to yourself. Just want to make sure you understood yourself. All right. All right. Cosine negative 630. Negative 630, so we go this way, what, 360, and then to 270, so we're here. Okay? Now, what happens when you're on a quadrantal? When you're on the quadrantal, you're just looking at your ordered pairs. You have to know that this is at 0 and 1. So it is 0. Remember, the reason that it is 0 is that when you're on a quadrantal, your x, oops, it's still xy, oops, so it's 0 and 1. Your radius of the circle is equal to 1, because it's equal to y. Your radius equals y. So the cosine value is still x over r, so it's 0 over 1, so it is 0. It still goes through that. That's when you start to get this. Cheers. R will always be equal. R, even, yes, it'll always be positive 1 because you use quadratic form, but Pythagorean theorem to go through those, okay? So on your quadrantal, your R value is always 1, whether it's at 0, pi over 2, 3 pi over, or excuse me, pi, or 3 pi over 2. It's always going to be 1, okay? I should have done this, yes, I know. I don't bend very well. I'm old. Old people don't move. Okay? So that's how quadrantals go. Stop me if you want me to do another degree one, or it's just going to go into radians. 14? Okay. Cotangent negative 30. So cotangent negative 30. I go down to the 4th quadrant. My reference angle is 30. The cotangent would be adjacent over opposite. So if I'm at a 30-degree angle, my adjacent is now root 3. My opposite is 1. So this becomes root 3 over negative 1, so it's negative root 3. All right? The mighty roar from the crowd. Yay. All right. Is some of the veil of scariness becoming too layered off?
Yeah.
Ladies and gentlemen, this is all this was the whole time.
Yeah, go ahead.
I'm trying to push you above the weight.
I don't think you were, Caleb. I hate to say that, I really don't think you were thinking.
No, I won't.
I really, yeah. Okay, what's that? Yeah, you guys were kind of little, that park was just awesome. Hey, I can't wait to talk to you guys later after you take the math one.
Wait, is it?
You guys are screwed.
We all
All right, radians. Don't say stupid, radians are important. Yes, ma'am.
If we finish the park this early, do we have to stay in the room until the certain time is up?
No, you get to go to your next class.
Yeah, because I was supposed to miss first, I was supposed to miss second, third period.
So there you go.
Just like everybody knew it.
So, now, one of the things you guys might start to recognize is hopefully a lot of times you can kind of get away with denominators. You may or may not be able to start figuring out what your reference angle is going to be in relationship to the denominator. Yes, sir? Oh, okay. A lot of times when you have something over 4, it winds up being 45. If it's a 6, it's over 30. So it's just a matter of knowing where you're spinning it to get to that reference, what quadrant you wind up in. 4 goes into 19 how many times? 4 with 3/4 left over. So we're going the other direction, so 1 little, 2 little, 3 little pi, 4 little. Now you have to go 3/4. 3/4 of the way.
After the half.
3/4, because I'm looking at 3/4 of a pi,
Yes,
so I should get to the third quadrant.
yes.
Okay? We know the reference angle is 45. It's a tangent value in the third quadrant, so will it be positive or negative?
Positive.
It's positive, and what's the tangent of 45?
Uno.
Uno. Okay, bueno. You get 1. It's positive 1. It's positive 1 because, remember,
negative 1 over negative 1.
yeah, negative 1 over negative 1, yes. Right. Here we go.
Would you, for the reference angle, would you keep it in radians? Since, you know, equations.
It's not asking, but here's the thing, it's not asking you to write down the reference angle. The reference angle for you in the triangles are 45s, 30s, and 60s. We're using the radian value to get to that triangle. All right? 6 goes into 31 how many times? 5. There's a 6 left over. So we're going negative, so 1 little, 2 little, 3 little pi's, 4 little, 5 little, and 1 6. So my reference angle, my reference angle is 30 degrees. I'm in the third quadrant, 30 degrees. Cosecant is the inverse of what trig function? Sine. So if sine is opposite over hypotenuse, cosecant would be hypotenuse over opposite. So 30 degrees, your hypotenuse is 2, your opposite is 1. Is sine positive or negative in the second quadrant? It's positive. Remember, it's the vertical component, okay? Izzy, remember, sine is the vertical component, all right? So here it's positive 2. You guys notice all the little thought process you have to put into each one of these. I spin it, identify where you're going to go, figure out what triangle you're using, and just slowly walk yourself through it. Miss Kate, what do you got? It's 2, you're looking at sine value. Your sine value, if I'm in the second quadrant, if this is my 30 degree, it's 1, 2, and this is the negative root 3. The sign is positive, because 1 is positive. 1 over 2, the opposite of 1 over 2 is 2 over 1.
Here.
It's just reciprocal, it's not opposite
Yeah,
reciprocal.
I just realized I didn't.
You're thinking full.
But then it's.
Yes, ma'am.
Would be a pi day
Oh yeah, we're gonna do that, don't we?
No, she's just wrong.
Why?
Because I know, just three, does she memorize one?
You still know?
I feel like.
Better than one of the other clusters we're gonna do. Alright, so no worries.
Only know for 10 o'clock park test for straight on. You need to report to M102C. Next Foster, W203. Again, for straight on, M102C. Next Foster, W203.
I'm gonna skip ahead real quick. I'm gonna skip ahead to show a couple of these, and then I'm gonna show a couple of inverses, and then, okay? On 23, the grouping into 23, this was the stuff we did at the very beginning of 8.2. They're telling you that the sine of some angle is the ratio 24 over 25. Sine, draw your triangle. Pick a theta. Shh. Ladies and gentlemen, come on. When you pick a theta, the sine value is what over what? So if this is my theta, this becomes, and this is? So what would this be? Good. Cosecant.
Cosecant is 25 over 25.
Right, you didn't need to know that, but the idea here is you're just solving for that missing side length for the right triangle and then working yourselves out into the other trig function. By just asking for cosecant, it's going to be 25 over 25.
I was confused because I thought it wasn't the right time. So I was like kind of.
They have to be. They have to be. Yes, sir.
I've been wondering this question the whole time. Is it a theta or a theta?
Theta, TH. No, you're not the only ones that's asked that. Other
I've always
classes,
been wondering.
it's theta. Theta, yes, theta.
I thought it was that. It's not fake. Oh, yeah. But you want to spell it out.
Theta.
That's
It's all right, no, you're not the only ones that asked that, all right? It's theta, yeah. All right? Now the last chunk.
Okay.
We'll get to them.
Yeah.
All right, I'm going to show a couple of these and a couple of the other ones.
When you say exact value, does that mean like decimal? Or?
No.
Word juice was bought in 8th grade.
Remember, in these types of problems, they're asking you what angle has a cosine of a half. What angle has the cosine of positive 1/2? When you do these, this is when you have to remember, you're between cosine between 0 and pi. Being 1/2, you have to think, what triangle can give me a ratio of 1 over 2? The 30-60. So if I draw it out, I know that if I put my 30 here, so this would be 1, 33, and 2. Yeah. Which of those angles has the ratio of 1/2? 60. 60 degrees has the ratio of positive 1/2. What is that in radians then also?
Pi over 3.
There you go. Yes, ma'am.
Two questions.
Yes, please. When you're doing whenever, it's a great question here, guys. Whenever it's asking you to find the angle that has this, or when you have the inverse function, get a radian and get a degree. Sounds fun, get a degree. Users. What's up? Yeah, I will. The next one says tangent of negative root 3 over 3. Now, when you're doing tangent, what can't tangent be?
It can't be like, whatever.
Can't be y-axis, so it can't be pi over 2 or negative pi over 2. Remember, your boundaries here, ladies and gentlemen, it's going to be between pi over 2, here's theta. Okay? That's your parameter for looking for this one. When I'm looking at tangent, to get a root 3 over 3, we'll come back to the negative value here in a second. Which one of those, which triangle gives me root 3s? 60, 90. Now, by it being negative, tangent's negative in the fourth quadrant. So if this is my theta value, excuse me, that means my y value is the negative. Are we okay with that? So, being root 3 over 3, wouldn't that be 30 degrees? Yeah. Negative 30 degrees, because then this becomes negative 1, and this is my root 3. That's how I'm able to get the negative root 3 over 3. So, for tangent to be negative, between between pi over 2, negative pi over 2, your answer would be negative 30 degrees, or negative pi over 6. Because that is not within this parameter. When you're finding the angles, you have to be within that value. What you did is you found a coterminal angle. Okay? What happens here is that you have to find your sine values for theta are going to be between pi over 2, less than or equal to theta, less than or equal to negative pi over 2. Cosine is between pi, guys, come on, and 0. And then tangent is between pi over 2, excluding.
So like you're finding the reference.
You're using the reference angle if you would have gone around to 11 pi over 6. Okay, you're kind of doing the same thing, but it's still that 30 degrees is your reference. Okay?
So I should never be getting like 11 pi over 6.
No. Because your answers for your angles have to be within these 3 parameters. That's how they find them. Yes, ma'am?
So, like, say if they gave you the inverse of tan and it ended up being on the 97 or 270, would that be a
Undefined.
solution or?
It would just be undefined.
Undefined.
Yep, it would be undefined.
Undefined number.
I think it might be. What was the number you wanted to look at again? Was it 30? 30? Okay. You got this?
Can you just like run through the answers from 70
Oh, I haven't done them all yet.
Really fast.
I haven't done it yet.
What?
I haven't done all the answers yet.
Because
Oh.
tan of
We could do 34 after.
All right, sine value, negative root 3 over 3, tells me that I'm going to be, excuse me, negative root 3 over 2.
Oh, wait, no, it would be, yeah.
That means I'm in that lower quadrant. The root 3 over 2 is 1.
It's just you need it.
So it's going to be the 60 degree again. Because that your sine value would be 60 degree. So it's going to be, since it's negative, it's got to be below, so it'd be negative 60 or negative pi over 3. Okay? That's how that one works for. Destiny, what number did you want to look at?
27 minutes. They're really fast. They're on the quadrant.
They're on the quadrant, the quadrantals, okay. So what angle has a sine of 1? Well, when you plot, you start with the parameters of where sine is found. You know it's got to be on one of the quadrantals. There's 3 of them here to choose from. 0, 1, 1, 0, 0, negative 1. Which one of those has a y value of 1?
The top one.
The top one, the 90 degrees, or cosine of 1. Cosine goes between 0, 180. It crosses the 90. So we have 1, 0, 0, 1, negative 1, 0. Which one of those is cosine 1? 0. That's what it means to work through the quadrantal.
You're saying 0 and like theory, is it just?
0 radians is the same thing as 0
You
degrees.
don't want like the not two.
You can leave it as 0. Yeah. It wouldn't be 2 pi because your cosine values are found between 0 and pi.
Okay, yeah. So like if ever again, just we can go through like the whole process of drawing it, or if we know that we know.
By all means, that's fine. How do I do what? What function do you use? Oh, I'll come to 1 second. Caleb, you want one of these?
Oh, yeah, 34.
I'm getting down there. I'm getting there, Rick. I'm getting there. Oh, the function thing. All right, so here's a function thing. All right? Sine of the inverse cosine of 0. Okay? This tells you order of ops. What angle has a cosine of 0? So, think about your cosine values. It goes between here to here. 1, 0, 0, 1, negative 1, and 0. Which one of those has a cosine of 0? 90. Okay? So at 90, that means this is going to equal, what is the sine then of 90 degrees? 1. That's all it is. When you wind up on the quadrantal like that, all you're doing is you figure out what angle has the cosine of 0. Well, 90 degrees. What's the sine of 90 degrees? 1. Done. You can, no, because this is not an angle. This is what is the sine of the angle that has a cosine of 0. That's what that's saying. What is the sine of the angle that has a cosine of 0? Sir?
How do you know that the cosine or the inverse, the cosine of 0 is 1? How do you know that?
Well, if you go back to just this problem here,
Yeah.
what angle has a cosine of 0? Well, cosine is found between 0 and pi. This quadrantal here has the ordered pair of 0 and 1. Cosine is your x value. So cosine, what angle has a cosine of 0? 90 degrees.
Oh, okay.
Oh. Wait, how do you find the sine 1 over 1?
Again, the sine of 1, or sine of 90 degrees, well, what's the y value?
Oh, okay. Maybe it just throws off because like triangles are like.
Yeah, I was trying to do the
I
triangle
know
thing
what
with
she's
the
doing.
A lot, quadrantals, triangles are tough to do. Sir?
It's the cosine.
I was making.
Well, you would find the sine, flip it.
Okay.
All right?
Okay.
Somebody had something. Good.
So we just have to like clear, if the y value is 2, then the sine of 90 degrees.
Let's do another one like that. Tangent of the inverse sine of negative 1/2. That says, what is the tangent of the angle that has a sine value of negative 1/2? Sine, you find that first. Negative 1/2. Negative 1/2, negative value. So you have 30, 60. So it's going to be at negative 30 degrees. You guys agree? Okay. So that means that this here is negative 30 degrees. So what you're asking now is, what is the tangent of negative 30? So now, you're no longer bound by the simple boundaries of the two quadrants. You have to find the reference angle. Well, this is easy. What's the reference angle for tangent at negative 30? 30. So now I have to figure out, all right, tangent of 30 degrees, 1 root 3. So it's 1 over root 3. So it would be this would be root 3 over 3. And is the tangent value positive or negative in the fourth quadrant? Okay?
I figured out.
Okay? I don't know how much of this stuff you guys have left to finish. I'm assuming you probably have quite a bit.
No, not.
38, I left that one there.
Yeah, what was 38 all about?
I did all of that.
38 is a whole lot like, what was it, 24, 25?
Yeah.
It's a whole lot like 24, 25. This is just, I mean, over the course of the next couple of days, we're gonna keep working on a lot of this, because you guys meet in and out, and coming and going and all that. So what I did here is I found, I think I was talking to you about this at one point. There's only so many of these problems you can do, because if you start to think about your unit circle is just, well, let's see, you got 3 in the first, so you have 12 angles, and then you have 16 if you add up to your quadrantals. Within those 16 angles, there's a sine and a cosine and a tangent. So you only have 16 times 3 is what?
48.
48. Now there's only 48 possible sine, cosine, and tangent angle values on one unit circle, but if you double it, you get all the inverses. So there's really only 96 total possible questions you can ask. I think we've asked about 93 of them. All right? Just keep working over these things over the next couple of days. There's the difference between the one side and the other. Well, these are all just finding the sine value. These are draw your placement, put in the triangle, yeah, and go from there. You're not finding the angles, they're giving you the angles on all these. You just have to find the value. Okay? Keep working on these things for the next couple of days. Yes, sir.